kind of my favorite part of this chapter to talk about. And before we talk about that, critical thinking, critical thinking is important for life, period. But it's really important when it comes to doing science. Okay, so there's 4 basic criteria. Critical thinking, broadly speaking, does, your textbook says making reasoned judgment about claims. What it really means is to question everything that, question what people tell you. Especially question it when you agree with it. Okay, so I don't know if you guys ever had to do this, but you might be given something to read and told, okay, write a critical essay, criticize this, whatever it is. And you might have noticed that it's really easy to be critical and think critically and question when you don't agree with something. It's a lot harder when you do, because you're reading along, oh, wow, that makes sense. Oh, yeah, man, I've been thinking that my whole life. Man, I agree with this guy, or this woman really got it, because you agree. The hardest thing in the world is to think critically about things that you agree with. So that's when it's most important. But here is the basic criteria. There are very few truths that do not need to be subjected to testing. So the scientific method is all about testing. Testing our assumptions, testing our biases, testing our hypotheses. Okay? Oops, we gotta do a little break for a person. I might have to stop when the people are.
Matthew.
Yeah, I don't have to stop. That's kind of interrupting. So. Okay. And I'll talk about that moment. We make hypotheses and we test them, right? Second, all evidence is not equal in quality. Okay? So we have a hypothesis, we'll talk about that, then we test it, and the science is about gathering evidence to support our hypotheses, or maybe evidence that shows our hypotheses are wrong, and they're going to support alternative different hypotheses. Okay, not all evidence is good. The way science works is we do research and we submit it to a journal, and then our peers, we have peer review, people who know as much as we do or more, look at it and decide, is our evidence good? Okay, so when you read about science or you hear about it on television or on the radio, and they'll talk, oh, they got evidence for this claim or that claim, then you gotta think, maybe there's 2 competing claims and people have evidence for both, right? People talk about this a lot. Right now in the news you see a lot of this. Well, but this scientist says this and this scientist says that. Your first clue is if 95 scientists say A and 5 scientists say B, you're probably going to go with the 95, right? That's your first clue. Okay, so science is all about repeating and repeating to get more and more evidence, because it changes, it evolves. But some evidence is better than ever evidence. And we'll talk a little bit about that now. And that's just what I was saying. Just because someone is considered to be an authority or have a lot of expertise does not make everything that person says true. As scientists, we test a lot of hypotheses and we do a lot of research. Truth is evolving. We learn a little bit more. We get a little bit more evidence. We might say something one day that is true as far as we know in that moment. Okay, that's happened to me with my research, and I haven't even done that much compared to some people. And then we might learn a couple years or a couple months down the line that there's better evidence for an alternative hypothesis, okay? And then, again, always question. Critical thinking requires an open mind. Like I said, you got to be open to being wrong, because you're going to be wrong. If any of you guys turn into research scientists, you're going to have to get really familiar with being wrong. I got a PhD, I got a doctorate. People always say, oh, wow, you must be so smart. And you don't need to be smart. It's just that you need to be persistent, and you need to have a really thick skin. Because people are going to poke holes in your ideas all the time. And you're going to say, I got a great idea, and you're going to run and study, and then you're going to discover you were wrong, okay? So bad scientists just, they have evidence they're wrong, and they just grab hold and they try to get more evidence. They manipulate the data. They say, oh, everybody else is wrong. No, that's not the way. You've got to have an open mind to everything, to all different ideas, and to the fact that you're going to be wrong. We all are. So question authority? How good is the evidence? Are there alternative explanations? Is the alternative explanation simpler? Okay, there's a thing called Occam's razor, and that just refers to parsimony. If there are two explanations and one is simpler, go with the simpler one. Okay? That's the law of parsimony. Open mind, delicate, critical thinking is a delicate balance between skepticism and willingness to consider possibilities. Life on Mars not likely, but if we had enough evidence, we would consider the possibility. Okay? It's all about evidence, and it changes as we go along. So, the scientific method. How do we get this evidence? How do we come up with